Okay, so we are going to continue from the last video. So we were able to implement the duck class and a class that basically is a subclass of duck class called mullet class. And then we had two interfaces, which was duck fly behavior and duck quack behavior. And then we had different classes that implemented those interfaces in order to solve the problem. Now we are going to talk about setting behavior dynamically. So what a shame to have all this dynamic talent built into our ducks and not be using it. Imagine you want to set the duck's behavior type through a setter method on the duck's subclass rather than instantiating in the duck's constructor. So we can add two new methods called set fly behavior and set quack behavior. And we can call these methods anytime we want to change the behavior of a duck on the fly. So make a new duck type model duck to Java. So we have a model duck extends duck, and we have a public model duck. A model duck begins life grounded without a way to fly. We have a quack behavior, and we have this. And make a new fly behavior type, fly rocket power. We have this. Then we have a mallet duck and we have a new model duck perform fly, set fly behavior, new fly rocket power, and then we have duck fly. Alright, so basically we are creating getters and setters. So let's just do that in the code. So for now we are going to have a setter here. So let's just call it public void set duck set the fly behavior, and that would be duck fly behavior. Let's just call it DFB. We can just mark duck fly behavior as DFB. Similarly, we are going to have a setter method for set duck quack behavior, duck quack behavior, DQB. We can mark duck quack behavior as DQB. So let's create a new class now called a model duck. So we have a model duck here. It extends duck class, and now we are supposed to handle the fly method. So must be declared. We should have a display public void display system.out.println. I am a model. All right, and then some things that we could have here is basically setting up some behaviors. So we can set up the duck. Basically, we can have uh, duck fly behavior, just like we did this in mallet duck. We can also override this method probably, and we can set this in the constructor of the model duck. So model duck will have the duck quack behavior as what kind of quack we have? We have a normal quack and uh, what else? We have a normal quack here and the fly behavior and then fly no wings, fly no wings. We can set it just like we did in the mother duck way. And yeah, let's create a duck model duck equals new model duck and yeah, let's create a rocket fly behavior. Rocket fly fly rocket This implements uh, duck fly behavior. We have a public void fly and I am flying on the rocket. They will just go ahead. Um, yeah, so how do we go about this? So we have a model duck here. We have a flannel wings. So in the end, we can just basically have some operations here. So model duck, like perform quack, model duck, like perform fly. Now we can just do a model duck that set the fly behavior new fly would okay. You can do that and perform fly. Let's see what happens here now. Let's just run this file. Alright, so first of all, I cannot fly, I can't walk normally. Uh, I am a mallet duck, I can fly as a mallet duck. But actually, moves this walk normally. I cannot fly, and then we set it. I'm flying on a rocket. Cool. The big picture on encapsulated behaviors. Okay, now that we have done the deep dive on Duck Simulator's design, it's time to come back up for air and take a look at the bigger picture. So below is the entire reworked class structure. So we have everything you'd expect: ducks, extending duck, fly behaviors implementing fly behavior, and quack behaviors implementing quack behavior. So notice also that we have started to describe things a little differently. Instead of thinking of the duck behaviors as a set of behaviors, we'll start thinking of them as a family of algorithms. Think about it in the SumU duck design. The algorithms represents things a duck would do, different ways of quacking or flying. But we could just as easily use the same technique for a set of classes that implement the ways to compute state cell stacks by different states. Pay careful attention to the relationship between classes. In fact, grab your pen and write the appropriate relationship is a hazard and implements on each arrow of the class diagram. Let's do this exercise then. Okay, so we have three options with us. These are hazard and so obviously mallet duck is a duck, redhead duck is a duck, this is also is a, this also is a duck has a quack behavior, has a fly behavior, fly with no wing is a fly behavior, or rather its implements uh, implements IMPL, 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 IMPL. Right, so we have the client and we have encapsulated fly behavior, encapsulated hook behavior. Has a can be better than is. Has a relationship is an interesting one. Each duck has a fly behavior and each duck has a quacking behavior, which delegates flying and quacking. When you put two classes together like this, um, wait a minute. When you put two classes together like uh, this, we are using composition. Instead of inheriting their behavior, the ducks get their behavior by being composed with the right behavior object. This is an important technique. In fact, we have been using our third design principle, favor composition over inheritance. We have to favor composition over inheritance. Master and student. Master grasshopper, tell me what you have learned from the object-oriented device. Student, master, I've learned that promise of the object-oriented way is your grasshopper granted. Master, through inheritance, all good things may be reused, and so we will come to drastically cut development time, like we swiftly cut bamboo in other words. Grasshopper is more time spent on code before or after development is cut. The answer is after. Master. We always spend more time maintaining and changing software than initial development. So Grasshopper should effort go into reuse about maintainability and extensibility. Master, I believe that there is a thread in this. I can see that you still have much to learn. I would like you to go and mitigate inheritance further. As you have seen, inheritance has a lot of problems and there are other ways to achieve reuse. As you have seen, creating systems using composition gives you a lot more flexibility. Not only does it let you encapsulate a family of algorithms into their own set of classes, but it also lets you change behavior at runtime, as long as the object you are composing with implements the correct behavior interface. Composition is used in many design patterns. We'll see a lot more about its advantages and disadvantages through this book. A duck calls a a duck call is a device that hunters use to mimic the quacks of ducks. How would you implement your own duck call that does not inherit from the duck class? So we will have, I think, a duck call behavior, which will be an interface, and the duck class will have has a relationship with this. Congratulations on your first pattern. You just apply your first design pattern, the strategy pattern. That's right. You use the strategy pattern to build the same UDAP app. Thanks to this pattern, the similar is ready for any changes those X might cook up in the next business review like this. Now that we have made you take the long road to apply it, here's the more formal definition of the pattern. The strategy pattern defines a family of algorithms encapsulates each one and make them interchangeable. Strategy lets the algorithm vary independently from clients that use it. Use this definition when you need to impress friends and influence colleagues again. Strategy pattern defines a family of algorithms, encapsulates each one, and make them interchangeable. Strategy lets the algorithm vary independently from the clients that use it. All right. What do we have to do now? These are some of the things that please don't oversee that 41. Right, so everything. So this extends that, this extends that, this extends that, this extends that. Um, Character has a knife behavior. Character has a bow and arrow behavior. Character has a weapon behavior. Or rather, uh, so character has a weapon behavior and knife behavior implements this and bow and arrow behavior implements this. This also implements this. sword behavior also influence this. And yeah, that's all there is to it. Set weapon could be uh set weapon belongs in this class and set weapon. Okay, I think we're done with the first chapter. So in the next video we are going to talk the second chapter, think pure.